A very pleasant morning, everyone. Today we are here for our presentation of Python Lab Video Submission 1. My name is Arun Sajujon and I'm here to present my assignment as a part of my PG Diploma course. So moving ahead, let's just discuss the contents of the presentation for today. First of all, we'll start by discussing the problem statement. We'll look into the solution from two approaches. One is the brute force method, and the other is a two pointer approach. Third, we'll look into the Python implementation in terms of both the approaches, and then finally, we'll compare both the approaches and then get ahead towards the conclusion. So, first of all, let's move ahead with the problem statement. So we are given the list that contains positive and negative integers where let's see the problem statement where we need to find two elements from a given list whose sum is closest to 0. For example, here in this presentation or a problem statement, we have been given two case studies, sample test case studies. One is where the sample input is -4762, -5, and once we take a sum of it, the sum which is closest to 0 here is -5 and 6. Hence, when taking up two integers whose sum is as close to 0, here the optimal solution is -5 and 6. Same goes with the other case test case scenario wherein we have the input that is shown on the screen, and the sum of two integers which is closest to 0 again here in this scenario is -38, 34. So let us move ahead with the first approach in terms of approaching this problem. The first one is the brute force method. This method employs the next state loop to systematically iterate through all potential pair of the element within the list. For each pair, this sum is calculated and compared to keep the track of the pair with the smallest sum. And finally, the element constituting the minimum sum are printed. Let us look into the Python implementation for the brute force method. So we have used the function sum minimum first, and first list size is designed to find two elements in a list whose sum is closest to 0. Here it is how it works step by step. So first of all, we'll validate the input. So within the input validation stage, the function first checks its list size whether it's less than 2, meaning there are fewer than 2 elements. If true, it prints invalid input and exits, as we need at least 2 elements for a pair. For the initial setup, it initializes minimum L and minimum R to 0 and 1, representing the indices of the first two elements, and minimum sum to the sum of these two elements, this 0 and this 1. These serve as the initial closest to 0 pair loops. So the third one would be loops through pairs. As nested loop iterates through every possible pair in the list, the outer loop index L starts from 0, while the inner loop index R starts from L plus 1, covering all unique pairs without repetition. Then we'll be calculating the sum and compare it. For each pair, it calculates the sum value. If the absolute value is smaller than absolute minimum sum, it updates minimum sum, minimum L, and minimum R to reflect the new closest pair. So eventually we have the result output, wherein after looping it prints the two elements with the smallest sum. Now we will approach this particular problem statement with the second second approach, which is the two-pointer approach. This is the specific example, the function that function creates the output which is closest to zero. In this particular technique involves a sorting. This sorting involves the listing in ascending order and then utilizing the two pointers that we will move towards each other in order to identify the pair whose sum is closest to zero. Let us look into its Python implementation. So we'll first of all set up a function and find the one which is closest, find close sum function. So first of all, we'll define that function and find two elements in a list whose sum is closest to zero using a two-pointer technique. We'll first of all sort the list and then we'll start initiating the values like the way I have discussed in the previous slides. We'll look into the input and observe whether if the list has fewer than two elements, it returns invalid input. Then we'll move ahead with a two-pointer loop. A while loop iterates as long as left is less than right. It calculates current sum for the pair at the pointers. If current sum is closest to 0 then minimum sum, it updates minimum sum and minimum pair. Then we'll adjust pointers. If current sum is negative, it moves left rightward, otherwise it would move left right leftward. The closest pair is then printed for the sample list. Now we'll look at the comparison of both these approaches. We have looked at the problem statement and we have obtained our uh, predetermined output that we wanted, the expected outcome. We have been able to get it. Now we'll just have a comparison between both of them. So in terms of brute force approach and the two-pointer approach, in terms of the time complexity would be big O n square, whereas for the two-pointer approach, the time complexity would be O n log n. Here, within the brute force approach, we use inner and outer loops to traverse through each possible pair. Whereas for a two-pointer approach, we use a two-pointer approach on a sorted list, assuming adjacent pairs are closest. Brute force is not suitable for a larger list, while two-pointer approach is definitely suitable for a larger list. The space complexity is 0, 1, whereas the space complexity is also 0, 1. Sorting is done in place with quick sort requiring no extra space, whereas for the brute force approach, no additional data structures are used as well. So finally, in the conclusion, I would say here we have discussed two distinct approaches to solve the problem of finding the two element with a sum close to zero. But we found that the method that the two-pointer approach is efficient and well adapted for the larger input, and it is exhibit a time complexity of order of n log n and a space complexity of order of 1. So thank you very much for your patient listening. Thank you very much.